So now, in electronic circuits, you see voltage dividers a lot. So you see resistance on one side, positive side of the power supply, and then resistance towards the negative supply. They meet in the middle. Now, this output is not for powering stuff. It's for sending the circuitry that looks at that voltage for the most part. You know, a little bit of current can be passed, but you want to try to limit it as much as possible. The main thing is, these resistors, or resistors in general, divide up voltage when they are in series. So you put them across the power supply, it's going to give you a fraction of the power supply voltage, whatever it is. So let's say this is a 9,000 ohm resistor, that's a 1,000 ohm resistor. This will be 90% of the resistance. So if you got a voltage that's being compared to 0 volt ground right there, you will have 90% of the supply voltage. If it's 10 volts, right here will be 9 volts. Again, it's a reference voltage just to be looked at. So now, if you want half of the supply voltage out by using a voltage divider, we got 5 volts here. Let's say we want 2.5 volts. Something looking at that voltage for whatever reason. You don't want to draw current though, but maybe it does draw a little bit of current. So 1,000 ohm resistors would probably be low, but you could use them. So they're equal value. 50% of the resistance is on the low side, 50% of the resistance is on the high side. So in relationship to ground, which is usually the way you go, you get half of the supply voltage. So like transistors and stuff need a little bit of current and whatever. You may have cases where you want a somewhat lower value resistor right here, but usually you use higher values. But it doesn't matter. As long as they're equal value, you'll get 2.5 volts out. And this one you can even provide a little bit of current. It won't pull that voltage very far. So now when you see a voltage divider that's trying to get half of the supply voltage, in this case we got 5 volts there, 0 volts at ground right there, you may see 10 kilo ohm resistors being used, especially if you got like op amps where they barely let any current in or out. You might even see higher values there if you want to limit the amount of current that you're wasting. But in any case, they're equal values. Half the resistance is on the low side, half the resistance is on the high side. Usually you compare it to ground right there, but you'll have half of the voltage that coming out. So it's a signal. It's just to look at that voltage. You really don't want to draw any current if possible from this at all. The more current you draw, the more it's going to pull it down towards 0 volts right there. But 10K should work if you're giving it to like an op amp or other input that doesn't let current go through, other than a very small amount of leakage. So now we're going to look at another way you may see voltage dividers, and we're going to use different voltages than in the previous example. So first we'll zoom in and kind of look at the voltage divider right there. So we have 10 volts that we're powering this circuit. Don't worry about what's over there yet. We got 1,000 ohms and 1,000 ohms for 2,000 ohms total. Main thing is though, that's half the resistance, that's half the resistance. So we got about 5 volts above ground there, and then 5 volts below the positive supply there. But in any case, it's 5 volts. Usually you do that in relationship to ground. Maybe you have to provide a little bit of current because of transistors or something. So these are kind of low values right there. But out of that 10 volts, in relationship to ground there, we'll have plus 5 volts, even though we got 10 volts at the supply. So we will have half the supply voltage. And we'll be able to provide a little bit of current because these are somewhat low value resistors. It won't throw it off too much as long as we keep the current relatively low. And again, we have another example of a voltage divider that's drawn in a way that you don't see often, but you may see from time to time. So again, we're going to use 10 volts. I'll zoom in a little bit. So if you're using 10K resistors right there, 10,000 ohm resistors, you probably assume that you're not really going to be drawing any current out of the output. But you got 10 volts there, half the resistance there, half the resistance there. Each resistor is going to have 5 volts across it. In relationship to ground here, you're going to have plus 5 volts across this resistor that you can use as a signal. So again, you really don't want to draw current. You're probably sending this voltage, if you're using it, to an op amp or a comparator integrated circuit with high impedance inputs. They don't really let current go through. Just a very tiny trickle flows through. But in relationship to 10,000 ohm resistors, that's practically no current. You will hold that 5 volts pretty well at that point. So now built into the 555 timer is 3 resistive areas, which we are representing right here. So Pin number 8 connects to one side of the resistive area as well to other stuff to provide power. But we're just looking at the resistive elements. And the pin 1 right there is connected to the negative power supply right there, and connects to the resistive element as well as other stuff, of course. Now you can adjust it with pin 5, but we're not going to worry about that. Usually you put a little capacitor to stabilize it, but you're probably okay without it. But in any case, you got 1/3 of the resistance towards the positive supply, so that gives you 2/3 of the supply voltage, because 2/3 of the resistance is towards the negative supply. Usually that voltage is in relationship to the negative supply. Whereas over here, you got 1/3 of the supply voltage right there, because 1/3 of the total resistance is to the negative supply in relationship to the negative supply.